Been looking, Annie, at conservation of momentum, and I've said to you that conservation momentum is a good tool when you have a collision between two objects, but it's also a good tool when you have an explosion. It's good for a collision or an explosion. It's good for a jeune. So let's look at an explosion. I like example one. I like example one. I like example one. Example one is a nice question. Says this: a rifle bullet leaves the muzzle with a velocity of 6.0 times 10 to the 2 meters per second. You know what? Let's add a direction. Lauren, what direction would you like the bullet to be traveling? North, south, east, or west? North, you say? So let's put a little arrow key right here and say north. If the rifle is held very loosely, with what velocity will it recoil? You might recall a few months ago, we watched a video of people firing high-powered rifles that were recoiling. It was a good example of Newton's third. So is there a collision here? No. But is there an explosion? Yeah. And you know what? Another good trigger that it's conservation momentum is if there's two masses. Is there more than one mass in this question, Lauren?
Say yes.
See the bullet and the 3 kilo. Okay. So if you want to, you can start out by saying the sum of all the momentum we start with is going to be equal to the sum of all the momentum we finish with. That's the law of conservation of momentum, how I chose to write it on your formula sheet, because that's the shortest way I can write it. Lauren, before we pull the trigger, what's moving? The bullet, the rifle, both, or neither? Be obvious. Don't panic. Before we pull the trigger, sorry? Good. So before I pull the trigger, what's my initial momentum as a number? Yeah, this is going to be kind of weird, but it's going to be 0 equals, and then I pull the trigger. Bang! The gun goes off. After I pull the trigger, what's moving? Well, definitely the bullet, but if the bullet is moving forward, which way must the... Both and separate. Okay. Remember lazy but organized? I'm going to use R for rifle. No, that's bullet, Mr. Dueck. Oh, I can turn that into a B. Haha, clever me. I'm going to use B for bullet, and I'm going to use R for rifle. And I'm going to say that, well, do you want north to be positive or negative? Pick. I'm going to put a little plus sign there to remind myself north is positive. I might even do that. Did I say I like this question, I like this question, I like this? Oh, I did. Okay. So I'm going to have this mass of the rifle, velocity of the rifle, and mass of the bullet, velocity of the bullet. There's my conservation of momentum. The momentum I start with has to equal the momentum I finish with. The momentum I started with is 0. The momentum I finish with is 0. And I think the only way that's going to work is if one moves forward and one moves backwards so that they cancel out. Lauren, what do they want me to find? Velocity. Yeah, which one? Rifle or bullet? Use a process of... Yes. Because which one did they give you? The velocity of... They want me to find the other one. As far as I'm concerned, Andy, I can give you either velocity and you can find the other one. I'm going to do my old, put a dot above that. Okay. How are we going to get it by itself? I guess first, Lauren, I need to move this over. How will I move that over? Yep. And since it's 0 minus that, I think all we're going to end up with is negative mass B, velocity B, and then look up, don't write this next bit down. In my imagination, I imagine this dropping down, but how would I get the VR by itself? How to move the mass rifle over? How to move the MR? Loud and proud. Yeah, so let's do that in one step without writing it out. So you can write this down. You could say, okay, it's going to be divided by that. And then if you want to, you can put the VR here. If you're okay with it, I'm going to put the there by itself. What's the significance of the negative? I'm going to get a negative answer. Well, what direction is the rifle going to recoil? More specific in this question, what direction is? Because you let north be positive, so Okay, I'm going to get a negative answer. Let's crunch the number. Oh, also because the rifle is heavier, will it be moving faster or slower than the bullet? What do you think? Hopefully way slower. Otherwise rifles would be the best peace invention ever created because anybody who pulled the trigger would die. So probably going to be moving much slower. It's going to be mass of the bullet, 0.06. I did a unit check as we went through. They're all good. Velocity of the bullet, instead of writing 6 times 10 to the 2, it's less work to write 600, so I'm going to do that. Divided by 3, not 3 plus the bullet, because they did definitely not stick together. They were stuck together beforehand, but since they weren't moving, who cares? This should work out evenly. In fact, I can do this at my 12 or 1.2. It's either a 12 or it's a 1.2. I can tell you that right now. Is it 12? Meters per second at which direction, Lauren? Yeah. Now, if you said negative 12, I'd probably, but here I gave you a direction. Don't say negative 12 south, because what's negative south technically? I would argue that's north. So you know what I'm going to do in my notes? I'm going to do this, Anderson. I'm going to write negative 12, and then underneath that, I'm going to go equals 12 meters per second at south. So when I'm studying, I know what my thinking was. If you go straight to the answer in your homework, I'm fine with that. Hannah, leave Maya alone. She's not worth getting in trouble over. Bonson Park, 3 o'clock. If I'm not there, just start without me. That's basically the whole lesson, but I want to show you a few cool applications as well. Example 2. I worked at a summer camp for 5 summers. Any of you have Miss Van Nuys as a teacher? Okay. Remember she taught across the hall, but she moved a couple years ago. I'm so old. I was her camp counselor. That's how old I am. I used to teach canoeing. Spencer is sitting in a canoe floating on the water next to a dock. He decides to stand up like this and step out of the canoe and onto the dock. Why will Spencer get wet? I used to see this happen all the time and just laugh. Why will Spencer get wet? Let's see if we can figure out the physics. Right now, with Spencer, you have to use me as Spencer analog. What's the momentum of Spencer in the canoe right now exactly as a number? What must it continue to be then? Okay, this is a slow motion explosion because Spencer and the canoe are separating. It's not an explosion, but it's a slow motion explosion. If Spencer moves to his right, which way must the canoe move? Who has a bigger mass, Spencer or the canoe? Spencer, which means the canoe is going to move faster or slower than Spencer steps. It's going to move faster. You may have tried this same thing if you've ever tried balancing on a water toy like an inner tube or something like that, and you go to try to dive off. You always end up belly flopping. Because why? What's your momentum of both you and the tube initially? 0. When you try and dive forward, which way must the tube move then? Say it out loud from the people on YouTube. Starts with letter B. Backward. What has more mass, you or the inner tube? You do. So what's going to move faster? The inner tube's going to shoot out from underneath your feet, and you're going to belly flop. You can explain the physics of that. Now, there's workarounds and things. But oh, you want to know how to get out of the canoe? So here's how I taught kids. First of all, you keep your weight down. Here's what I taught them, okay? Turn sideways. Have I changed the momentum at all? No, it's still 0. Sit down with your butt on the dock. Now you've got a source of friction. Lift one leg over, you can do it that way. Or get somebody else from the dock. By the way, if you have somebody else, now it's no longer a closed system. We've got an external force acting, holding the canoe against the dock. That works. Or you can grab the dock with your other hand. Again, not a closed system. Now, yeah, you can get out. But for a closed system without any help, only way to do it is to turn sideways, keep your momentum 0, carefully sit down on the dock. But don't sit down on the dock in such a way that you're pushing the canoe away from you to get your weight to go sideways. You got the argument? I don't want to write a big paragraph. Let's see. How about this? If capital S, what's capital S an abbrev for in this question? Be obvious. Spencer moves left. Capital C, what's that an abbrev for? Canoe moves right, but faster since since smaller n. Is that clear enough, Evelyn? That makes sense? Okay. I used to see it all the time. Little kids, I would always help. Adults, I'm going to let them get wet because they need to learn. They would stand up and try and step out in a big step. Yeah. Arrows, you know what? That's what I should have done. I should have used arrows. Yep. By the way, a couple of you looked at me a little skeptically, like there's zero momentum on the water. Really? Oh yeah. Watch, 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 watch. This is a really neat video that a physics teacher put together of his son on a paddleboard. Okay. What's the momentum of the boy and the paddleboard right now, of Carl and the surfboard right now? Be obvious. Okay. If Carl walks forwards, what must the surfboard do? Watch. And I'll bet you these masses are pretty close. Small kid, big surfboard, not that big a discrepancy. There's a tiny bit of friction from the water, Angus, but water nearly frictionless enough. It's very calm water. Yeah, zero momentum. Example 3. You may have done this when you're ice skating. Turn the page. How many of you, when you're ice skating, have got close toe to toe, head to head with a friend? You put your hands against each other and you both push off of each other and just see how far you can go backwards without skating. Little kids do that all the time. So here, a 45-kilogram boy and a 60-kilogram girl are standing in the middle of a frozen pond. The boy gives the girl a push as shown. By the way, forces come in. So if the boy gives the girl a push, what? Girl's also giving the boy a push, yes? She moves off with a speed of 2.4 meters per second. With what velocity does the boy move off with? I'm going to argue this is an explosion because it's two things coming apart. That's really what I mean by an explosion. I don't mean something goes off really, really loud. I mean things coming apart. That's an explosion. Uh, can I go lazy but organized? G for girl, B for boy. Again, if you want to use mass A and B or mass 1, go ahead, but pick letters that are easy to remember. Okay, so Cody, before the explosion, who's moving? The boy, the girl, both, or neither? Okay, so this is an explosion. In our notes, I'm going to say that means we can use conservation of momentum. The sum of the initial momentum has to equal the sum of the final momentum. And what is my initial momentum exactly as a number in this case then? After the explosion, who's moving? I think both and separate. It's going to be mass of the girl, velocity of the girl, plus mass of the boy, velocity of the boy. I'll put vector signs above the V's. Cody, in this question, is there more than one direction? So I'm going to have to let one way be positive, one way be. Do you want the 2.4 to be positive or negative? I'm good with that. Lazy but organized. Boom. Am I expecting to get a positive answer for the boy's velocity or a negative answer for the boy's velocity? What direction is the boy moving? To the? What direction did you say was positive? To the? You said left was positive? So am I expecting to get a positive answer or a negative answer for the boy's velocity? I'm expecting a positive. I'm positive. It's going to look like this. 0 equals, what's the mass of the girl? 60. Velocity of the girl, negative 2.4, using Cody's reference frame, plus, wait a minute, Mr. Dueck. Why am I plugging in numbers right away? I should have gotten the V by itself, shouldn't I? That's sloppy of me. You can leave it the way it is. Cody, let's get, which V are we going to get by itself? This one. How are we going to do that? I think we're going to minus VG MG, yes? Minus MG VG, and then divide by? By the way, what if the two kids are identical masses? Same velocity. Yeah. Is the boy lighter or heavier? So is the boy going to be traveling bigger than 2.4 or smaller than 2.4? So there's some built-in error checks if you look for typos or whatever. Now let's plug in numbers. It's going to be negative mass of the girl 60, velocity of the not yeah, oh, also negative again, negative 2.4. You said we were going to get a positive answer. Are we getting a negative times a negative? Yeah. Right? What is a negative times a negative? Okay, I'm probably setting this up right. Divided by 45. I can do this in my head. 60 over 45 divided by 15 divided by 15. It's 4 over 3. So it's going to be 3.2, I think. And for a direction, I'll say to the right, I guess. Jordan, is that okay? Okay. Jordan, what's B want me to find? Impulse. Okay, now I'm looking just at the boy and I'm looking at the impulse equation. Now, the impulse equation, don't write this down because it's on your sheet, but it says something like this. I can't remember the order that I wrote it, but it says it's those three, right? Delta V. What was that? Whoa. Which one of these am I going to use? I don't see a force and a time, do you? But do you see two different velocities? I think I'm going to use this version. So this is what I'm going to write down. First of all, impulse is change in momentum. So I'm just going to write delta P. That's my abbrev for impulse. But it's going to be M boy V boy final minus M boy V boy initial. I wrote this in my notes this way because this is what you're using to study from. But Davin, what is the initial velocity of the boy exactly as a number? Yeah, Jordan, you could have skipped writing that term. I wrote it out just to let you know if it wasn't zero, that's where the initial velocity would go. Jordan, what's the mass of the boy? Was it 45? Velocity of the boy, 3.2. I could do this in my head. 45 times 3 is going to be 135 plus 9. Is it 100 and 144? Double check me. 144 units. You know, you're right, because we went mass times velocity. The units are sitting there. You could also write Newton seconds. That works, but since we didn't go force times time, I probably wouldn't use that. Kilogram meters per second. Good. Yeah. But here's the problem, okay? This is not impulse. Impulse is your change in velocity, which is always final minus initial. The only reason going straight to mass times velocity worked was because VI was zero. Here, where I'm being a little concerned is you're saying, Mr. Dueck, couldn't I just said the impulse was the momentum? Well, the change in momentum isn't always going to be the momentum, so I'm reluctant to say do it that way all the time. But in this case, yes. Yeah. I'm picking my words very carefully on purpose because what you said is technically wrong, but it'll work in this situation. Oh, what's the impulse of the girl, Hannah? What? Oh, I was about to say too slow, but you came through for me. Almost the same. I have to be fussy. It's not 144. Delta P of the girl, negative 144 kilogram meters per second. And when you add those two together, positive 144, negative 144, what was the overall change in momentum? Zero, because that's what the law of conservation of momentum says. Momentum doesn't change. You started with zero, you ended with zero. You can have an explosion for a moving object as, oh, sorry, there's a D. If the push lasted for 0.25 seconds, with what average force did the boy push the girl? You could go F equals what? MA, and you can find A. But what did I just find, Carson, in part C? Is there a version of impulse that has a force in it? It doesn't by chance also have a time in it, because that's what they gave me. Does it? Oh, can you get the F by itself in that version of impulse, please? This is what I keep saying, that impulse equation, you can survive without it, but it's a nice shortcut because it's going to be negative 144 divided by 0.25. What's the negative telling me? If they want a direction, I guess it's left. They didn't say magnitude and direction. They just said average force. But if you're wondering what the negative is telling me, there is a direction there. I can do this in my head. Dividing by 0.25 is the same as timesing by 4. So it's going to be 400. It's going to be 568? No, 572. What is it? Sorry? 576. I carried a 4 wrong. 576 units. It's a force. You could say that, or you could say 576 newtons at, well, for the word left, I don't know if I need an at symbol. Left. I didn't include north, east, south, or west. You can also have an explosion when you're moving. So here's a space capsule. There is an explosion. I even see the bang right there. Spoiler alert, there's going to be a bang. A space capsule consists of a 2,500 main capsule and a 1,500 kilogram probe. The space vehicle is traveling 120 meters per second when an explosion boom, occurs between the capsule and the probe. After the explosion, the probe moves forward at 280 meters per second. What's the new speed of the main capsule? I can make some predictions. Did the probe speed up or slow down? Did it gain momentum or lose momentum? It sped up, so did it gain momentum or lose momentum? Gained. So what did the space capsule do? So I can tell you right now, this is going to be going slower than 120. You know what? In fact, the explosion could have been so big, it might even be going, I don't know, it could even be going backwards. I'll find that out if I get a negative answer. I don't know. So, are you ready? Here we go. Anderson, you good? What would be a good letter to use for capsule? What would be a good letter to use for probe? I realize there's going to be a P for momentum and a P for probe. The subscripted P will be probe. The non-subscripted P will be momentum. Deal with it. There's only some. Have I mentioned we don't have enough letters in the English? I hope I have once or twice. Okay. There's an explosion, so I would start out by saying the sum of all the momentum initial has to equal the sum of all the momentum final. Anderson, before the explosion, what's moving? The capsule, the probe, both or neither? Stuck together or separate? How do I show stuck together? Brackets. It's going to be this. The mass of the capsule and the mass of the probe, same velocity. Yeah. Bang! The probe goes off. Explosion. Sorry for those of you watching on YouTube. Have you started watching the momentum lessons on YouTube yet? Because you're in for a treat when you get to the collisions and explosions. Wear really sensitive headphones and have the volume cranked. Or not. Afterwards, I think both and separate. Yes? It's going to be mass of the capsule, velocity of the capsule, final, plus mass of the probe, velocity of the probe, final. Anderson, what do they want me to find? Right there. Okay. This is a little complicated. No, I can handle this. What side is the VC on? The right? So what side is the VC on? The right? What's going to drop down like a domino? The left. And I'm running out of room here. I didn't leave enough room. I need to reformat this. But it's going to be that plus that, V initial. Talk to me, Anderson. Now what? Yep. Mass probe, V probe final. Then what? Nice. And I'm going to put the V capsule final right there. Let's see if I can fit this in on one line and get an answer. I hope I can. I hope I can. I've scrolled down. What was the mass? Oh, didn't it tell me the whole thing just weighed 4,000? You know what? I'll just put a 4,000 there. You could put the separate 2,500 plus 1,500, but since they told me it's 4,000, I know that's right. What was VI? That can't be VI. Oh, that I'll live with. And then there's a minus sign, and the probe was 1,500 kilograms. And how fast did it move off at? And I guess we're letting to the right be positive, just in the sign notation that we've used here. All divided by 2,500. I'm really not sure where this is going to go. Might get a negative. I don't think you're going to get a negative answer. I'm doing some quick math in my head. Do you get a negative answer, or is it positive? It'll work out to a nice decimal, I can tell you that. It's not going to be a yucky repeating going on forever one. Anderson, what'd you get? Really? Even? Don't count on stuff working even. That's always a fluke when it happens, because I don't care about you enough to go through the trouble of doing that. 24 meters per second if they ask for a direction, right or forwards. You know what, though? It lost almost all of its momentum, didn't it? Because it was originally going 120. Now it's going 24. If the explosion had been a bit bigger, the capsule might have ended up going backwards. Or we could have ended up with the capsule at exactly 0. That would have been all the momentum going for the probe. That's what they try and do with 3-stage rockets. You try and set it up so that all the momentum gets transferred to the probe, to the next stage, and none of the momentum is left with the previous stage. What's the magnitude? What did I say? Magnitude? I didn't give you enough here to do direction of the impulse given to the probe. That's a good question. Well, impulse is change in momentum. So Maya, go. Did you get the right answer? Okay. Do you want me to look at your calculator? I'm not sure what you said. Were you okay? Okay. Going back to your earlier question, Maya, where you said, can't I just go mass times velocity? And not here for the impulse, because nothing is 0. It wants us to find the impulse in part B, Maya, on what? Okay, so I'm going to go delta P, which I know we're using letters over. That's going to be mass probe V final plus mass probe V initial. I knew that because I just found a final velocity and I don't see forces. In fact, you know what? I think they gave me all the information. What was the final velocity of the probe, Maya? I think they told us. Sorry? Probe. What? Oh, 2. I didn't hear the 2. Sorry. So it's going to be 1,500, 280 minus 1,500. What was the initial velocity of the probe? Yeah, because they're stuck together. We will get a positive answer because the probe in our reference frame, in Anderson's reference frame, letting right be positive, definitely gained momentum. I have no idea what the answer is. Ooh, do you get 240,000 units? Kilogram meters per second, because it's mass times velocity. Yeah. Oh, I put a plus up here. That was dumb of me, Carson. Candy for you. You're right. This should be a big fat minus, shouldn't you? Yeah. Thank you for catching that. I did it right in my numbers, at least. Why is it minus? Because change in anything is what? Final minus initial. Yep. Hannah, what's the answer to C? 240,000. If you wanted to, you could say negative. I don't care. Yeah. Because momentum is conserved. The capsule lost that much, the probe gained that much. I think we got a couple of more thought puzzles and then we're done. Mountain climbers use nylon safety ropes due to their tendency to stretch considerably under stress. Why would you want the rope that's bringing you to a stop to stretch? What would increasing time do? How would it decrease? Well, you don't want to hit the ground. That's the idea behind the ropes is you don't hit the ground unless something's gone horribly wrong. Lower the acceleration. Yeah, yeah. Oh, you know what? What's a good abbrev for increase? An up arrow, I think. Nathan, let's write this. Time increases. That leads to an acceleration decrease. Now, Hannah, you're right. You have to be careful. You don't want it to stretch so much that you hit the ground before it's brought you to a stop, but they would know the stretch per every 10 meters or whatever, and that's when you would put in your latest piton, your little hook, and you would be aware of that if you were doing serious mountain climbing, serious rock climbing. But yeah, you definitely don't want a rope that brings you to a stop instantly. You want it to stretch a fair bit. Ideally, it would gradually bring you to a stop. Why does conservation momentum explain why it's so difficult for firefighters to hold hoses that are ejecting large amounts of water at a high speed? Has anybody here used a real, actual fire hose? Nobody here in the fire academy? Okay. You have? Their work. Yes? Yeah. It's not like you're holding it with one hand like a garden hose. Okay. Just you yourself or you and several kids holding in a row? Just you? How old were you at that time, roughly? Okay, so that gives me a rough idea of your mass. Good. Why does conservation momentum explain why it's so tough? Well, right when you open the hose, what's the momentum of you and the water before you open the hose? What must it be afterwards? So if the water has a bunch of forward momentum, Davin, you gonna make it? You back? Wakey wakey. If the water has forward momentum, what? Yeah, and we can think of it in terms of impulse too. The water has a force times time pushing it forwards, which means you're going to have a force times time pushing you backwards, which means you're going to have to apply a force. Now, it's not a closed system. A closed system would be if you were doing that on ice. If you were opening a fire hose on ice, you would go skating backwards. There's an extra force, and that's the friction between your shoes and your feet and the ground, which as an 8-year-old you didn't have enough of because friction is mu times the normal force, not a very big normal force. And if you were sitting, even less friction. Okay. So let's say this. Oh, what's a good abbrev for water? 3 letters. Well, 2 letters and a number. H2O has forward impulse. So firefighter has backward. Oh, what's a good way to abbrev impulse? Delta P, but I don't know how to do a delta symbol, so I'm going to write the word impulse. But you could certainly put a delta P in there. Yeah, if you've ever used a fire hose for any length of time, it's a workout. Is that all right? One more, we're done. The diagram below shows 2 pop cans of unequal mass. In fact, it looks like one is mass M and the other one, Carson, is mass what? Twice as heavy. They're initially at rest. An explosive charge is detonated between them and they fly apart. What can you tell me about their velocities? Let's be lazy but organized. How about we call this can A, can B? What can you tell me? Velocity of can A is going to be 2 times the velocity of can B. If can B flies off at 10, can A will fly off at, way to do the math in your head. Okay. Says, using principles of physics, explain your answer. Let's see if we can do a proof. Before the detonation, what's the momentum of the cans, Nathan? And then afterwards, we're going to have mass A, velocity A, plus mass B, velocity B. I'm hoping to show that the velocity of A will end up being twice the velocity of B. So let's get the velocity of A by itself. By the way, you know what? I should have put a negative up here, shouldn't I? They are going to be in opposite directions. I should have said the velocity of A is going to be negative 2 times the velocity of B. Let's do that. Subtract what? Yep. Then what? And you're saying that's going to be the velocity of A? Okay. What is the mass of B? 2m VB. What is the mass of A? What letter did they use? Just plain old? Is there an M on the top? Is there an M on the bottom? Did I just get what you argued, that the velocity of A is equal to negative 2 times the velocity of B? QED is from a Latin expression that means quo eritas demonstrandum. It means which was to be demonstrated. We used to joke in math that it stood for question easily done, and was the biggest lie on earth, because in math and university we were usually doing 3 or 4 page proofs that took probably 50 or 60 steps. But once you got at the end, this was like spiking the touchdown. QED. Proved. We're done the unit. What's your homework? I'm going to give you a take-home quiz. That's your main homework. You'll get tomorrow. All we're going to be doing is marking the take-home quiz. I'll give you time to work on this. I'm going to hand out a study guide. But number 1 is good. Number 2, I stole this from the internet. This is about every type of collision that I could come up with. So it looks like in A, they stuck together. It looks like the 13 had no velocity at the beginning. So here's small moving object run into heavy object at rest. They stick together. How fast are they traveling after? I tried to kind of mix and match every possibility. So try number 2. 3 is good. 4 and 5 are kind of identical. Do you want to jump off a floating raft, or do you want to explode a bomb? I'll let you pick. Bomb. Okay, do 5, skip 4. 6 is good. You can skip 7. You can skip 8. 9 is good. Hannah, what are the units next to that 310? Sorry, what? Sorry, I missed that. What are the units? What are the units next to that 500? Okay, I don't know why I'm saying that. I'm just I thought I just mentioned that. 10 is cool just for a thought puzzle. You don't actually have to do it. If you read it and think about it, it'll make sense. Skip the uranium nucleus. Do I want to do the nasties? I'll pass on those for now. I've thrown a lot at you. Okay. But let me give you the take-home quiz first, please. That's really what you're going to work on. So